Hello everyone, here we are going to discussing derivatives. Derivatives means how particular parameter is changing with respect to some other parameter. Means how a variable is changing with respect to some other variable. For example, here reservoir overflow example here. When will a reservoir overflow? Knowing the depth of the water at several time intervals. A second example is a rocket example here. Rocket scientists need to compute the velocity at which the satellite need to be shoot out from the rocket, knowing the height of the rocket at various time intervals. Now the definition is, suppose f is a real valued function and a be the point in its domain of the function. Okay, here f is the real valued function and a is the any point in its domain. Now the derivative of the function f at a point a is defined as the this is the limit value function, that is limit h tends to 0 f of a plus h minus f of a by h. This is the derivative of the function at a, so it is denoted by f dash of a. And one more notation is there, limit h tends to 0 f of x plus h minus f of x by h. This definition is denoted by f dash of a, but this definition is denoted by f dash of x. Okay, this is also known as is the first principle of derivative. This is the first principle of derivative. Examples. The first one is, find the derivative at x is equals to 2 of the function f of x is equal to 3x. By using this definition here the given function is f of x is equal to 3x and a value is 2. So now f dash of 2 equals to limit h tends to 0 f of 2 plus h minus f of 2 by h. So by using the definition like this, limit h tends to 0 f of 2 plus h means here f of x value is 3x. So f of 2 plus h means 3 into 2 plus h. Okay, 3 into 2 plus h minus f of 2 means replace x by 2 here. So 3 into 2 by h. So now we simplify, limit h tends to 0, 3 into 2 6 plus 3 into h 3h minus 6 by h. Here plus 6 minus 6 cancelled out. Limit h tends to 0, 3h by h. Here h is again cancelled, that is equals to 3. So this is the derivative of the function f of x is equal to 3x at the point x is equal to 2. Now the second example is, find the derivative of the function f of x is equal to 2x square plus 3x minus 5 at x is equal to minus 1, and also prove that f dash of 0 plus 3 into f dash of minus 1 is equal to 0. Given function is f of x is equal to 2x square plus 3x minus 5 and x is equals to minus 1. By using the same definition already used in the above, we want to find here f dash of minus 1. Now substitute the f of minus 1 plus h in the given function like this, minus f of minus 1 means replace x by minus 1 in the given function like this, 2 into minus 1 whole square plus 3 into minus 1 minus 5 by h. After some simplifications, we have the value like this, that is limit h tends to 0, h into 2h minus 1, here h cancel, the remaining value is, then we apply h as 0 here, 2 into 0 minus 1 is equals to minus 1. Okay, now we want to find f dash of 0 like this. Now f dash of 0. So by using the same notation here, definition here, limit h tends to 0 f of 0 plus h minus f of 0 by h. So substitute the given the value 0 plus h in the given function like this. Minus 5 minus f of 0 means 2 into x square means 2 into 0 square plus 3 into 0 means 0. So 3 into x means 3 into 0 minus 5 by h. After some simplifications, we have the value like this. Limit h tends to 0 to h plus 3. Now we apply h as 0. 2 into 0 plus 3 equals to 3. So f dash of 0 is equal to 3. Now we want to prove like this. We want to prove what is we need to prove here, f dash of 0 plus 3 into f dash of minus 1. Yes, f dash of 0, what is f dash of 0 here? That is 3 plus 3 into f dash of minus 1 value is this is minus 1. So plus 3 minus 3 is 0. That is our proof. Here some important note, the notation, how we notate or denote the given function as a derivative. Here derivative of f of x is defined by f dash of x or denoted by f dash of x or d by dx of f of x. If y is equal to f of x is given, then the derivative of f of x is dy by dx or d of f of x. And second note is derivative of f of x at x is equal to a is also denoted by d by dx of f of x at x is equal to a or df by dx at x is equal to a or df by dx at x is equal to a. These are the notations for denoting the given derivative of the given function. Now algebra of derivative of functions. Here to define algebra of derivative of the given function, we have two functions f and g with their derivatives are defined in a common domain. The first one is addition and subtraction rule. Derivative of f of x plus or minus g of x is equals to derivative of f of x plus or minus derivative of g of x. And the second one is product rule. D by dx of f of x into g of x is equals to f of x into derivative of g of x plus g of x into derivative of f of x. That is, this formula can also be written in UV form if we put u as f of x and v as g of x. So uv whole dash is equal to uv dash plus vu dash. And third one is quotient rule. D by dx of f of x by g of x is equals to denominator g of x into derivative of numerator d by dx of f of x minus numerator into derivative of denominator by denominator whole square, that is g of x whole square. This is the quotient rule. This formula can also be written in UV form as u by v whole dash is equal to vu dash minus uv dash by v square. The fourth one is constant multiple rule. D by dx of c into f of x is equal to c d by dx of f of x. Here c is a constant. Now other note is by using the standard formulas here, derivative of constant value is always 0 and a derivative of x power n is equals to n into x power n minus 1 into d by dx of x. Now by using this we want to find derivative of trigonometric functions. So the first one is derivative of sin x. By using the first principle we solve this derivative of sin x by simplifying in this way. To find the derivative of sin x, we have a limit x tends to 0 to cos 2x plus h by 2 into sin, here x cancelled, h by 2 whole by 2. So now we apply h as 0, then we have cos x into 1. So the derivative of sin x gives cos x. Therefore, derivative of sin x is equals to cos x. So this is the proof. The derivative of sin x is cos x. Now what is the proof of derivative of tan x? By applying the same formula as above and some simplification like this, we have limit x tends to 0. Here the numerator value is cross multiplied. We have some standard forms like this on limits. The first standard form is 1 and second standard form is limit h tends to 0. 1 by cos x plus h is cos x into cos x, that is cos square x. 1 by cos square x is secant square x. So this is the derivative of tan x. So what is the derivative of tan x? Is secant square x. So by using this method, we find